Hello everyone, welcome to Computer Science Hub. Our subject is Computer Fundamentals and this is the part 3 video of our topic Algorithm and Flowchart examples. In our previous examples, we have discussed some examples of how to draw an algorithm, how to draw a flowchart and write algorithm for specific problems. And in this example also, we will be discussing some more problems, okay? So our first question is to check whether a number is prime or not. So before starting, let's discuss what is the concept behind the logic behind this prime number. What is a prime number? Prime number will be a number greater than 1 and it is having factors as 1 and the number itself. That's the definition. So consider a number, suppose 3. Consider 3. Then we know every number will be having two factors, and one is number 1 and the next factor is the same number, which means 3 is equal to 1 into 3, right? When we consider the number 6, we know every number is having two factors. Of course they will be having two factors, one is 1 and other is 6, and 6 have another two factors. They are 2 and 3, right? 2 into 3 is equal to 6. Okay, similarly, so this is the concept behind prime number. A prime number will be having only 1 and the number itself as their factors. Okay, here we can clearly say that 6 is not a prime number because it contains other factors. Okay, but 3 is prime because it contains only 1 and 3 as its factor. So the prime number is a number greater than 1. So to start from 2. 2 is a prime number. Then 3 is another prime number. 5, 7, 11. Okay, these 13, these are prime numbers. So now to check whether a number is prime, the step is suppose consider number 11. To check whether 11 is prime or not. So if number 11 is prime, it won't be having any factors other than 1 and 11, right? So our step is to divide the 11 by the numbers starting from 2. Okay, divide 11 by 2 and check whether it is divisible by any of the number. Okay, so divide 11 by 2, we will get a reminder, right? We will get a reminder, which means get 1 as reminder, which means 11 is not divisible by 2. So 2 is not a factor of 11. Then consider the next number 3. 11 by 3. Of course, there is a reminder. So 3 is not a factor. Then divide 11 by 4. There is a reminder. So 4 is not a factor. Then 5, 6. Okay, like that. So, and we probably, we may think like we have to divide up to 10, right? 11 minus 1. 11 is a factor we know. So we have to check up to 2 to 10. But that's not the case. We just need to check for half the numbers. Okay. 11 by 2. Half of 11 is 5, right? 11 by 2 is 5. So we need to check only the numbers 2, 3, 4, 5. Okay. If any of these numbers are not the factors of 11, then surely the next half. Next half is 6, 7, 8, 9, 10. Okay. Next half won't be the factor of 11. Okay. So the thing is, we just need to check for half of the numbers. Check for half of the numbers and divide that numbers by divide 11 by these numbers and check whether there is a reminder or not. If there is no reminder, or I mean if any of this number is divisible by 11 can be divisible by any of these numbers, then that number is a factor of 11. So 11 is not a prime. But here we won't get we will get reminders when we divide 11 by all these numbers. So 11 is a prime number. Then consider another number like 10. Okay, 10. Oh no, just take 9. Okay, 9 divided by 2. 9 divided by 2, we will get 1 as reminder. So I increment 2. Next number 3. 3. 9 divided by 3, but 9 is completely divisible by 3, right? So we will get 0 as reminder. So the process stops because 9 is not a prime number. This is the concept. Okay. To check whether a number is prime or not, we will repeatedly we will take the numbers from 2 up to the number half of the number. Okay, if the number is 10, then we will check up to 5, like that. Okay, half of the number we will take each number and divide that our number. Then if we get reminders, then we can say that the number is prime. Okay, so let's start with our algorithm. Declare variables. We need three variable, mainly ni and flag. Initialize the flag. Initially flag is set to 1. Okay, and our I loop variable I is set to 2. Then read n from user. We need to read a number from user and check whether that number is prime or not. Okay, so and that number is stored here, n. If n less than 1, we can clearly say that a prime number is a number which is greater than 1. So if the value of n is less than 1, then n is not prime. Okay, if less than or equal to 1, okay, that's the case, n is not prime. You can print like that. Else, and we can directly go to stop. Okay, go to step 7. Step 7 is stop. Or which means n is greater than 1. Okay, repeat the steps until I is equal to n by 2. Okay, repeat the steps until I equal to n by 2, which means we take I value first. Initial value of I is 2, and we take numbers from 2, 3, 4, 5 and up to n minus 2. Okay, n is our number, n by n by 2, half of n. Next, repeat these steps until I is equal to n by 2. And these steps need to be repeated. First step is to, if remainder of n divided by I equals 0, which means simply n percentage I equal to 0. That is when n is divided by I, if there is any remainder or not. If there is no remainder, then n percentage I equals 0, right? In that case, we can say that the number is not prime. So we set a flag. Flag is set to 0, and we go to step 7. In step 7, we check flag and print whether it is prime or not. Okay, we will see it later. Then 6.2, next step to be repeated is increment I. I is incremented to I plus 1. Okay, which means if there is no reminder, I suppose our number is 6, and I divide 6 by 2. Sorry, not 6. Let's take our number is 7. I divide 7 by 2, and I get a reminder, right? So I get a reminder, then I will increment I. So I is incremented to 3, and I will divide 7 by 3. Again, I will get a reminder. So again, I increment I, and I is 4. Then each time when we increment I, we will check this condition whether I reached n by 2. Okay, here it is 7. 7 by 2 is 3. So up to 3 we need to perform this operation. Okay. Then after I reaches n by 2, or when the flag is set to 0, here we can say see that go to step 7. Okay, in these two cases we go to step 7. When I reaches n by 2 or flag is set to 0, we reach step 7. In step 7 we check whether if flag is equal to 0. If flag is 0, we can say n is not prime. If flag is else, we can say n is prime, then stop. Okay, so this is the concept. Let's trace out with an example. Mm, a bigger, no, okay, consider a bigger example, our 11 self. So first step is to n is 11. Okay, the next step is to find out the half of 11. 11 by 2 is 5. So n by 2 is 5. Half of 11 is 5. Then initially flag is set to 1, and our I is set to 2. Then here checking, we are doing this loop, and 2 equal to, we perform this steps until 2 is equal to 11 by 2 is 5. Okay, when 2 reaches 5, until when 2 reaches 5. So first step is to find out the remainder, right? So 11 by 2. In case of 11 by 2, there is a remainder. So we can increment I. I is incremented, which means 2 got incremented to 3, and here 3 is equal to, okay, 3 is less than 5, that's okay. So 11 by 3, again there is a reminder. So again I got incremented to 4, and here also 4 is less than 5, so we can continue. And 11 by 4, here also there is a reminder. So again our I got incremented to 5. Then again 11 by, here 5 is equal to 5, we can continue. So 11 by 5, again there is a reminder. Then we will increment I becomes 6, and here I is equal to 6 and our n by 2 is equal to 5. So this condition got violated, which means we can stop and move to the next step. Okay, move to step 7. So only we need to check half of the numbers. If half of the numbers are not the factor, then another half won't be the factors of our number. Okay, so next checks for the flag, and our flag is initially set to 1, and during our loop we didn't change our status of flag, so our flag is not 0. Flag is, we can go to this else portion and display n is prime. So it will print like 11 is a prime number. Hope the logic is clear. And this is a flowchart. Flowchart is a simple one. Starting with terminal start, then flag equal to 1 and I equal to 2. Read n from user. Then check whether n is less than or equal to 1. If it is yes, means our number is not prime, we can directly print n is not prime and move to the stop. Okay. Next, check whether I less than n by 2. If I less than n by 2, we will do another loop, right? And in that loop, we will check n percentage I equal to 0. If there is reminder or not. If there is no reminder, what we will do here, we will increment I, right? In this algorithm we will increment I. Similarly here also we increment I, and after incrementing I we will check the value of I reached n by 2. Okay, so this is our loop goes to here, the input of this decision statement, and here I am, it will check like I less than or equal to I less than n by 2. Okay, this is one loop. And here when n percentage I equal to 0 become true, which means there is a factor, so the number is not prime, right? We have to set the flag. For that there is a yes path. In yes path we set the flag equal to 0, and we'll go for checking the flag condition. Okay, flag status bit. Then, when this condition violates, I mean, I got incremented, and again we check for the status of I and n. When this condition violates, the next step is to take the no deviation. Okay, this is the yes path. Then this is the no path. When the value of I is greater than n by 2, again we can check the status of our flag, right? So checking whether flag equal to 0. If flag is equal to, this is not 0, flag is equal to 1. Okay, if flag is equal to 1, we can say that n is a prime number. Not, if flag is equal to 0, we can print n is not prime, and after stop. Okay, so this is our problem. Next question. Program to print first n prime numbers. So this is same, in part 2 video we discussed about the even numbers. Okay, and in that even numbers we checked whether a number is even or not, and we had print first n even numbers, right? Similarly, to print first n prime numbers, and here logic is the same as our previous problem, and we will take a limit. Okay, we will take a limit. Suppose I have entered limit as 10, so I need to print first 10 prime numbers like 2, 3, 5, 7, 11, 13, up to first 10 prime numbers. For that we keep a separate variable called count, and the count is initially set to 0. When the first prime number is printed, count is incremented to 1. Like that, when the second prime number printed, count is incremented to 2. Okay, when the nth prime number printed, count will be incremented to n. and that is the concept. Next step, let's consider the step 1 is start, of course, read the limit n, then set count is equal to 0, then num is equal to 2. So here another thing is, suppose I set the limit as 5. So what I will do is, I will consider the numbers starting from 2. Okay, I will check whether 2 is prime. If 2 is prime, I will print 2. Then count is incremented. Then check whether 3 is prime. Yes, if 3 is prime, print 3, and count got incremented to 2. Two prime numbers are printed. Then I will check for 4, and 4 is not prime. So I won't print anything and I won't increment anything. Next case is 5. So check whether 5 is prime. 5 is prime, right? So 5 got printed and our count is incremented. Then again a number got incremented to 6. I just check for 6. 6 is not a prime number. Next number got incremented 7. 7 is prime, so we'll print 7, and our count got incremented to 4. Then next is 8. 8 is not prime. Then next is 9. 9 of course not prime. Next is 10. It is not prime. Then next is 11. 11 is a prime number, so 11 got printed, and our loop, I mean our count becomes 5. Okay, so when our count reaches limit, we can stop. Okay, so here count reaches 5, so we can stop. This is the logic. Set count is equal to 0 and the number is equal to 2. Repeat the steps until count less than or equal to n. Okay, when the number count is less than or equal to n, we can do perform these operations. Okay, don't think let's set flag is equal to 1. Flag is set to 1. Then again I is set to 2. Then these steps are same. We had discussed in our previous problem. These steps are the same logic. Repeat the steps until I less than or equal to n by 2. If reminder of, so we will start with checking 2. So our num is 2. Then check whether num is, I mean 2 is prime. If then these are the same steps. Increment I, then check for 3, like that. Okay. So here when we exit this loop, the step 7, we check for the flag equal to 1. If the flag is 1, our number is prime, so we can print that number, print num, and count got incremented. Otherwise the flag is 0, so our number is not prime, so just simply increment our number. If we consider the number 4, then just increment the number, so our number become 5. Then again the steps repeat. If I reminder I is set to 2 and 5 percentage 2, then the steps repeats. Okay, and every time num got incremented, we just check whether our count reached our limit. Okay, so step 10 is stop. The concept is very simple. All that we need to do is just put this much steps. These steps we already discussed in our previous example, and just put all these steps inside a loop, this loop, which means set a count, and until the count reaches our limit, we need to do all these things. Hope the concept is clear. Next is the flowchart, and this flowchart is a little bit clumsy, but start, count is set to 0 and num is set to 2. Then read n from user. Then count less than, we are checking whether count less than or equal to n. If it is yes, we can proceed. Flag 1 and I 2. Then again checking I less than or equal to num by 2. If it is right, then again check n percentage I equal to 0. If it is not, then you can increment I, and this step got repeated until I less than or equal to num by 2 condition fails. So when it is no, directly check for the status of flag. If flag is 1, we will print the number because the number is prime. If flag is not, we just increment our number. If we are considering a 2, then we just increment that to 3. That's it. Okay, and here when n is equal, n percentage I equal to 0, which means our number is not prime. So again we set the flag is equal to 0 and check for the flag value. And at last, when num got incremented, each time num got incremented, it will check whether the count reached the n limit. And when count reach the limit, we will stop. Next question. Find root of the quadratic equation ax square plus bx plus c is equal to 0. And this equation is very much familiar. All of us study this in our basic mathematics. Okay. Then the roots of this equation are given by minus b plus or minus root of b square minus 4ac by 2a. Actually, this algorithm is a very simple one. We need to by heart, or we need to study all these equations. These equations are we have studied this equation during our school time, right? So this formula is called as quadratic formula, and here the term b square minus 4ac is known as the discriminant. And this term discriminant is important because it tells you how many roots an equation may have. So if this b square minus 4ac is less than 0, our equation do not have any real roots, but it having complex roots or imaginary root. We know the complex number I. Okay, that concept. If it is equal to 0, our equation having a single one real root. If it is greater than 0, then there are two real roots. Okay, these things we need to implement. So starting and declare the variable a, b, c, d, r1, r2, rp and ip. These variables we need during our algorithms. Then calculate discriminant. Discriminant value d is equal to b square minus 4ac, right? For that b into b minus 4 into a into c. Then based on this value of d, we have to do three different functions. So when d greater than 0, when d greater than 0, display our roots are real and calculate the root. These are the root. R1 is equal to minus b plus root d by 2a. R2 is equal to minus d minus b minus root d by 2a. And then we can print R1 and R2 as roots. If d, else if d equal to 0, if the value of d equal to 0, then display roots are real and equal. Then the value of that root is R1 is equal to R2 is equal to minus b by 2 into a. Okay. Next step 6, else. That means a d is not greater than 0, d is not equal to 0, which means d is less than 0, right? If d is less than 0, roots are imaginary. These are the to find out imaginary roots, we need two parts, real part and imaginary part. So real part is rp, real part is equal to minus b by 2a. Imaginary part is root minus d by 2a. Then form the factors, I mean form the roots as rp plus I into ip. Okay, rp is the real part plus I into, I means our complex number I into imaginary part. Then next root is rp minus I into ip as roots. Step 7, stop. This algorithm is very simple, only thing we need to by heart all these roots. Okay, next, this is the algorithm and it is also a simple one. This is the flowchart. Starting, then declaring the variables, then calculating the discriminant b square minus 4ac, b into b minus 4 into a into c. Then the decision value is the value of discriminant. If we are checking d greater than or equal to 0. It is not true means d less than 0. Okay, so the right side, no side. No side, we need to find out the real part and imaginary part, and our real part is equal to minus b by 2 into a. Our imaginary part is equal to root minus d by 2 into a. Then form the roots r1 and r2. R1 is equal to this real part plus I into imaginary parts. So rp plus I into ip. Then r2 is equal to real part minus I into imaginary part. rp minus I into ip. Then we can display this value of r1 and r2 and move to stop. Okay, is d greater than or equal to 0 is true. Okay, yes. Then there are again two cases, if d is greater than 0 or d is equal to 0. So when d is equal to 0, is d is equal to 0, this is another checking. Yes, If d is equal to 0, we know that there is a single root, and the value of that root is r1 is equal to r2 is equal to minus b by 2 into a. This is the root, and we can move to display r1 and r2 and stop. Okay, this is finished. Then is d greater than d equal to 0 is no, which means our d is greater than 0. So d is having two real roots, right? R is equal to minus b plus root d by 2 into a. R2 is equal to minus b minus root d by 2 into a. Then move to display r1 and r2 and finally stop. This is the concept. Hope the problems are clear. Thank you.